Okay, so this is something related to bromination of phenol and aniline. So this molecule PHOH is called phenol, and this molecule PHNH2 is called aniline. If you treat phenol with bromine Br2, you will have a orthoparol position which basically gets halogenated. So this Br, you will have here also Br, here also here you will have a Br group. If you do the same thing here, are you getting? If you do the same thing here, that is NH2, now Br will go here, this Br will also go here, this Br will also go here. Are you getting? So you can do basically tribromination. If the problem is, if somebody wants to do monobromination, what can we do? What can he do? Can anybody give me some hint? Okay, so what we can do is we can basically decrease the reactivity of OH. So basically what electron OH and NH2 what is doing is giving electron plus R, and that's why electron is going inside the ring, so ring becomes very activated. So these are activated rings. So decrease the activity of phenol and aniline. Basically we use one kind of trick, and the trick is, if we have OH and if you treat this compound with anhydride, if you treat with acetic anhydride, or you can take any anhydride, basically this is called acetic anhydride CH3, you have COO, COCH3. So this is coming from acetic acid. So this is a 2 molecule of acetic acid you take, and loose water will get acetic anhydride. So this is acetic anhydride. If you treat this compound, you will have something like this, COCH3. First let me ask, can you derive this product using the mechanism? I will give you a hint. Now this carbon and double bond O, basically there are positive charge on this carbon. So what this oxygen can do, this oxygen, what we have to do? We have to attach this oxygen with this group. So simply, we have to attach this oxygen with this group. So I will think in the back. So here you have the same group. So I will think in the back. What we will think is, can I attack this on this carbon, open up, then I will have H plus, lose H plus, and then this is also a good leaving group, so then I can remove this one. I will let me do this one, and then you do the next problem yourself. So what we can do is, I can take phenol OH, there is a lone pair, and then you have CH3, C double bond O, OCOCH3. Now if this attacks here, this opens up because it cannot have more than 8 electrons, so you will have something like this. See, let me write O here, OH, because it does not matter, O. Here we will have CH3, are you able to see or not? And here we will have O minus, OCOCH3, COCH3. Are you getting? In the next step, if you lose H plus, you will have this O, CO minus, CH3 and OCOCH3. Now after this step, something will happen that we have not discussed yet. Now this negative charge, basically there are 3 lone pair. This lone pair can push this bond, and this can basically go up because this is a good leaving group. So this is a leaving group because negative charge is stabilized by the oxygen. This is coming from acetic acid. Acetic acid is a not very strong acid, but of course this is acid. Acid, so this has some character. So if you have the more stronger acid, leaving group ability increases. So this is acid, so it will also have some leaving group character. This means this comes here, this goes. So if this happens, we will have something like this, O, CO, CH3, and then it will gone with this one. This molecule is gone, O minus CH3, nothing is there. So nothing is there. Are you getting? So this is simply O minus CH3 COO minus. You are getting this compound that you have to derive this product. So let us first copy. So you copy this one. If you have not copied something on the top, you can again copy. And then we will go on the bottom part. Have you done this? Okay, so now see, now this molecule, so we have converted phenol. So what we task is, we have converted phenol into OCOCH3. Now this compound is basically not so reactive because this lone pair can go this side, and this is also in the resonance with this side. So this lone pair does not in this side more. This side is also. So now reactivity of this ring decreases. Now you can do monobromination. And after that doing the monobromination, so if you want to do monobromination, if you do Br2, you can attach a bromine group at para position because para is major. You will have ortho and para both product, but generally para product is major product, OCOCH3. So let us attach one Br here. So you will have ortho plus para both. Para will be the major. Now what is the advantage is, now if you do let us say hydrolysis, if you treat this compound with H3O plus, this will be converted into OH. So this goes, we will discuss sometime later also this one, Br, and this is finally converted into OH, that is the hydrolysis. So if you treat with H3O plus, this group will finally convert it into, so this means if I simply say you convert this to this, you cannot do. If you take bromine, you will have tribromination derivative. But if you take indirect path, you first convert into this. That if you treat with acetic anhydride, you will have this, and then you do bromination. You will have only monobromination, and then you do here you have the monobromination product, and then do hydrolysis. You will have the final product. Are you getting? So let us copy fast, and then we'll discuss. Have you gone or not? If you have understood, we can do the same thing with NH2 group also. Are you getting? We can do the same thing with NH2 group also. You can derive yourself. So mechanism will be same and everything will be same. So let me show you here. So you can do the same thing with NH2 group also. So let us say somewhere here. So let us take a new page. So if you want to do, so if we have this NH2, you can first make this into, this is called acetylide. So you first make something like this, NHCOCH3. Now the reactivity of NH2 decreases. Are you able to see or not? So you can convert this into this, and reactivity of nitrogen decreases. So this goes this side, this goes also this side. So reactivity decreases. So what you will do? You first treat this compound with CH3CO, OCOCH3. That is same as, I can also write the same thing, something like this, CH3CO 2 times CH3CO, this group is called acyl group, CH3CO, this side also CH3CO, so CH3CO 2 times and 1 oxygen. Same thing can be written something like, in short I can write something like this. If I treat, once again nitrogen lone pair will attack here, this open, returns back, this goes. You see the same mechanism we have discussed in the last case. We will have this NHCOCH3, and then do bromination. You can have one bromine here, and then you can do hydrolysis. So if you do bromination Br2, you will have only one bromine that gets attached, and then you do hydrolysis, the last thing whatever we have said. So you understand, if you do hydrolysis, finally you will have something like this. Here you will have NH2 group, and at para position you have bromo group. Are you getting? So this is quite good way to prepare a mono derivative of aniline, mono halogen derivative of aniline or phenol. So what we do is reactivity of phenol and aniline can be decreased by reacting with acetic anhydride, and this is called acetanilide. So let me write the name. So this is called acetanilide. So this is called acetanilide, and that is called acetate. So the previous one will use phenyl acetate. So leave that one. You remember the name of this only. So this is called acetanilide. Even if you don't remember the name, there's no problem. You simply know the mechanism. Why we react with acetic anhydride. So this is acetic anhydride. Why we react with acetic anhydride to decrease the reactivity of phenol or amine. And once we have decreased the reactivity, only monohalogenation will take place, and then we can do hydrolysis to get back to the same compound. If I do the hydrolysis, I will have amine NH2 group. So this is NH2 group. So if I do the hydrolysis, I will get the NH2 group. Are you getting or not? So I will get the NH2 group after hydrolysis. So acetanilide can be hydrolyzed back to amine. That is the important point. So I have an acetanilide, and if I want to hydrolyze this one, I will get the amine. That's the final conclusion. Same thing in the last case also. If you have pH OCOCH3, if you do hydrolysis, you will get phenol. So you can basically fast convert into different group, do some reaction in the molecule, and then do hydrolysis. You will get back to the same compound, original compound. And what is the advantage? Advantage is you can only do monobromination or monohalogenation. You cannot do in this case trihalogenation. Why? Because of the reactivity of benzene rings decreases. Because once you have formed this one, this lone pair can go this side. This can also go this side. So chance of going this side decreases. Chance of going this side decreases, because now it can go this side also, it can go this side also, so chance decreases. So aniline basically becomes less reactive in this case. Okay, so let us copy this one, those who have not copied, and then we'll discuss the next problem. Okay, let us discuss the next problem.